それでは続きまして、オーラルプレゼンテーション9、直方体から正八面体に変化する NaCl 結晶、ポリアクリル酸ナトリウムによるミラー指数111面の安定化、富山県立富山中部高等学校の皆さんです。どうぞ前へお進みください。山沢明宏さん、伊藤良平さん、宮崎幸太郎さん、松倉敦さん、横山愛子さん、折山泉さん、石川優里さん、戸ヶ部影虎さん、指導は浮田直美先生です。それではよろしくお願いいたします。
We are going to talk about the change in NaCl crystals from cubic to octahedral. Sodium polyacrylate stabilizes the 111 phase of mirror indices. We are the member of Super Science Chemistry Club of Toyama Chubu Senior High School. I'm Izumi Moriyama.
I'm Aiko Yokoyama.
What do you think is the shape of sodium chloride crystals? And how are the ions in sodium chloride crystals arranged? Maybe you saw crystal like this shape, because this is stable. This is structure and lattice of NaCl crystal. When we apply stress to rock salt, it cleaves due to a shift in ion layers, so it becomes cuboidal crystals. Cuboidal is a shape that all the surface is rectangles. So do you know mirror indices? There are many cutting phases of crystal, and one of the diagonal cutting phase is 111 phase. This phase is unstable because the same charge ion coordinated and forms 111 phase. One day, we found floating ghosts of NaCl crystals gradually developed, and the shape of the crystal surface in contact with air was equilateral triangle. By X-ray diffraction, this surface was found to be a 111 phase. But why does the unstable 111 phase of NaCl crystal grow while suspended? Buoyant force and surface tension work to floating NaCl crystal, and the range of the equilateral triangle is larger than square. So the crystal with 111 phase can get more surface tension. But the crystal was small and changed to a cuboid shape after it sank. We wanted a big crystal and all the surface is 111 phases. So we want other methods by which 111 phases become stable in NaCl solution. And we found by adding 2% or 4% sodium polyacrylate as habit modifier, regular octahedral NaCl crystal grew gradually in saturated NaCl solution. And all surfaces of the octahedral crystal are considered 111 phases.
These are the purposes of our experiments. In saturated NaCl solution with sodium polyacrylate, we wanted to find out rock salt crystals in the zone change from cuboids to octahedrons or not. Also, by adding small amount of polyacrylate into saturated NaCl solution, we wanted to find out if this change possible or not. To check our theory, we did 3 experiments. Experiment 1, changing forms of cleaved rock salt crystals in supersaturated NaCl aqueous solutions with sodium polyacrylate. First, we used supersaturated NaCl aqueous solution with 2% sodium polyacrylate. We made this dough become supersaturated by natural evaporation, and we put cleaved rock salt into the salt and we sealed the top of the beaker with paraffin. These are the results. All the cuboid crystals changed gradually to their regular octahedral forms on the bottom of the beaker. After 70 days, the crystals became complete octahedrons. These octahedral crystals' volume increased, so we expect that we can get bigger crystals. Secondly, we use a low concentrations of sodium polyacrylate. We put We mix 5 different concentrations of sodium polyacrylate into the saturated NaCl aqueous solution. We put chloride salt into each solvent saturated NaCl aqueous solution. Then we seal the top of the beaker with paraffin. These are the results. All the crystals became shapes like flat-topped burial mounds, which are one of the common in ancient times in the East. Also, the crystal volume decreased. The same change was seen in NaCl saturated solution containing no sodium polyacrylate, so we thought that all the crystals slowly dissolved because the NaCl solutions were not supersaturated. So we verified our hypothesis. We observed the changing forms of chloride salt crystals in 5% NaCl aqueous solutions. The crystal dissolved like this, so this result means that the previous crystals were also dissolved. Then we replaced the paraffin of each beaker with gauze to allow the salt to evaporate gradually and reach a supersaturated state. These are the results. All the crystals in sodium polyacrylate changed to a pyramid shape, and no octahedral crystals was observed in the NaCl aqueous solutions. We continued these experiments by turning over the crystals. Then all the crystals grew to octahedrons.
Next, experiment 2. Growing NaCl crystal deposit in saturated NaCl aqueous solution with low sodium polyacrylate by natural evaporation. In this experiment, we made 5 different concentrations of sodium polyacrylate and covered the beaker by gas. After a week, we observed the deposit on the bottom with an optical microscope. These are the results. We observed many small or microscopic crystals which had 111 phases in all NaCl solution with sodium polyacrylate. And this goal is similarly to crystal in high concentration of 2% or 4%. This is a discussion. Crystal growth follows the direction of the stable energy. We thought there are 2 main factors. First, electrostatic interactive energy between ions becomes lower by touching different charge ions. So 100 phase is electrostatically stable, and 111 phases are unstable. Second, surface energy becomes lower by making surface area of crystal smaller. We know that surface area of octahedron is below 5% from a cubic surface of the same volume. So 111 phase is stable. So why do 111 phases stabilize in sodium polyacrylate? Large quantity of water is absorbed, internal space of the polymer expands. Then the repulsive force generated from many carboxylate anions. By adding Na-cation binding carboxylate anion, the repulsive force becomes weak. So surface energy of the NaCl crystal becomes lower. And Cl anion is put to Na-cation, so 111 phases stabilizes. Next, experiment 3. Forming NaCl crystal on the boundary surface between saturated NaCl solution and NaCl salt with 6% sodium polyacrylate. We added 6% sodium polyacrylate to NaCl saturated solution and poured NaCl saturated solution into the backpack. This is the result. octahedral crystal appeared. So why did octahedrons appear? We thought crystals can grow in every direction while suspended condition.
Also, we did other experiments. First, we used KCl. We expected that the KCl crystals change like NaCl. KCl is an NaCl type crystal, but KCl crystals grown in the soil with sodium polyacrylate were formed differently. These KCl crystals have several diagonal cutting faces. Second, we observed the changing the shape of a big crystal to understand the changing coordination of the surface of the crystal. We made a big cube of clipped rock salt sunk in saturated NaCl solution with sodium polyacrylate. Then, the crystal is becoming like a spherical. In conclusion, by adding sodium polyacrylate to NaCl saturated solution, cubic crystals with 100 faces changed to octahedral crystals with 111 faces. Because sodium polyacrylate stabilizes 111 faces, the Na cation and Cl anion coordinate to minimize the surface area smaller. Also, low concentration sodium polyacrylate causes the NaCl crystal shape change. These are future tasks. We have just talked about researching whether the cuboid shape of NaCl crystals changes using other carboxylate anion habit modifiers. We are deeply grateful to Professor Kiyosuke and Professor Hitoshi Miura for their assistance for our research. These are references. Thank you for listening.
ありがとうございました。それでは次応答へと移らせていただきます。ご質問のある方、挙手をお願いいたします。はい、ではマイクをお持ちいたします。
すごくよく研究に取り組まれている研究で大変感謝しました。今回一応ですね、111面をポリアクリル酸で成長速度を成長コントロールされている実験だと思うんですけれども、これの温度依存性は測定されてましたでしょうか。成長、要するにポリアクリル酸の賠償剤と使って111面安定化させていると思うんですけれども、この実験の温度依存性の測定をされていることはありますでしょうか。
すみません、もう一回お願いできますか。すみません。
今回のそのポリアクリルアミドを賠償剤と使ってて111面の安定化を図っていると思うんですけれども、この実験に際しての温度依存性の測定をされたことはありますでしょうか。
では、すみません。
というのは多分これ熱力学的な安定、表面の安定性を見越して作業仮説として表面の安定性を賠償剤として作用させていると思うんですけれども、念のために速度論的な支配を排除する必要があるかなと思ってますので、温度依存性のデータを取ったらええやないかなと思ったんですけど。
すみません、それってポリアクリル酸の粘土による
粘土ではなくてその、実験に対しての温度を変えたという。
はい、ありがとうございます。NaCl は溶解度が変わらない、温度によってあまり変わらないため、あまり温度による
ありがとうございます。溶解度の話ではなくて、その表面との間の相互性を見るためには多少温度の依存性を見た方がいいのではないかなと思います。
ありがとうございます。
質問通じてるような。
すみません。
ちょっと温度のですね、データ見てください。それで熱力学で分かると思います。はい。
ありがとうございます。この他ご質問ございましたら、挙手をお願いいたします。質問の方はいかがでしょうか。はい。では、マイクをお持ちいたします。お願いいたします。
同じ立方体を作る結晶で、なんかその NaCl と違うイオンの並び方するやつは、なんか試されたことは
KCl を先ほど言いましたが、塩化カリウムを用いて実験をしました。
イオンの並び方が多分一緒やと思うので、全然イオンの並び方が違う試されたら、その面積の効果が比較できる。
ありがとうございます。今後試してみます。
ありがとうございます。それではお時間となりましたので、以上で質疑応答を終わらせていただきます。富山県立富山中部高等学校の皆さんでした。ありがとうございました。